Hi lecturer, we are from group Kopiko. My name is Wei Yang and my group member Goh Bing Shen, You Zhen and Yap Xuan Yu. Today we are presenting our cloud computing project for the student management system. Now I will present a phase one which is build a simple system. First, we look at our VPC configurations. As you can see from the resource map, we established a dedicated virtual network called Kopiko VPC with a CIDR block for 10.0.0.0 per 16. Following cloud-based practice, we implement a multi-asset strategy across ability zone 1A and 1B to provide a solid foundation for high availability and fault tolerance from the outset. Moving on the network partitioning, we organize our subnet into two distinct routing groups. For the public tier, we associate our public subnet with a route table that directs traffic to the network gateway. Meanwhile, we also configure a private router table for our sensitive back-end tiers, effectively isolating them from direct internet access to enforce a security network boundaries. Next, move to the security groups. Regarding the security system, we implement a stateful virtual firewall named Kopiko Web SG. Adhering the principle of least privilege, we meticulously open only the essential ports, which is the port 22 for the administrator has hash access and port 80 and 443 to allow the web traffic from the public internet to ensure our management system is both accessible and secure. Now let's look at our core computer resource. Which is our Kopiko web servers. We provisions a T3 micro instance running Amazon Linux 2023 within our public subnet. For secure administrative access, we associate this instance with a Kopiko key pair. On this server, we manually insert the LAMP stack comprising Linux, Apache, MariaDB, and PHP to host our application code and manage local student records. Now, finally, we would like to demonstrate the live application by accessing our public IP address. And this is our homepage of the student management system. Now, click on the View Students. You can see the record from our database. Furthermore, I can perform the full CRUD operation. I can add new students. As you can see, already successfully add a new student, Goh Bing Shen, and now I also can edit the informations. And also delete the informations with real-time synchronizations. And this is successfully conclude the phase one. Now I will pass to the next presenter to continue the phase two.
Alright. Good morning. My name is Goh Bing Shen, and now I will be going on phase two, which focus on migrating the local database from the EC2 instance to manage the service using the Amazon RDS. So now let's look at the security group first. So I have created the Kopiko database security group, and I click on it, and here's the inbound rule. And I have a load of MySQL Aurora, which is port 3306, and allow the set the source to the security group of the web server. It is to ensure that no one from the public internet or even from other resource within my VPC can access the database. So now let's move on to the database subnet first, and we go through the RDS and go to the subnet group. And here's the Kopiko DB subnet, which I have created. So for the configuration, I have configured this group to include the private subnet in both availability zone of the 1A and 1B. It's to ensure the future scalability And by having the multi-exec, I can easily upgrade the database to multi-exec deployment in the future without require any entire network infrastructure. So now let's move on to the database. So here's the database that I have created. So here's the name of the database RDS, Kopiko DB, and we move on to the configuration. And the instant class, we have used the T3 micro, and the engine version is MySQL 8.0. And we can show that here is the master username and the master password, which we already equipped up. So here you can see that the multi-exec already become null because I have set it to the single exec, which to optimize the cost, as multi-exec deployment can make the cost increase fast. But however, as I have mentioned just now, the underlying network is already prepared to support the multi-exec, so I can easily to modify the multi-exec. So now let's move on to demonstrate the connectivity of the RDS. So we go on to the EC2 first, and we click on the instance, and I use this and click on the connect and connect the EC2, and you will be redirected to the EC2 connect. So this is the base, and let's look at the database configuration of the web server first. So let me go on to the DS endpoint, and the username is Kopiko as the master username that I mentioned just now, and here's the password. So the database is listing in here. So let me show the database EC2 database endpoint first. So we have linked the endpoint and copy it and paste it in here. So now we go on. So here we can see that the student list has this out using the table. So we go on to this student list and we try to edit one person. I change the name to the Andrew and I set it. Okay, so let me show the updated. So now here we can see that the ID 10 of the student name already changes to Andrew. So the data already updated, which show the decoupling is successful, allowing for the better performance and isolate the security management. So that's all for the phase 2. Now my friend will continue to present about for the phase 3.
Good evening, sir. My name is Yap Xuan Yu, and I will be presenting on phase 3. In this phase, I will explain two key components, the target group and the application load balancer. Now let's move on to the target group. So over here, we can see that we had created a target group named Target Kopiko. The reason we had created a target group is because the application load balancer cannot directly send traffic to an EC2 instance. Instead, it must forward target traffic to a target group, which then manage the instance inside it. So next, we will move on to the application load balancer. Over here, we have created an application load balancer called Kopiko ELB, and it is developed across two subnet located in different availability zone. The reason for having two availability zone is to improve high availability. If one data center or one exec fails, the ALB can still operate from the another availability zone. This prevents downtime and ensure users can await access to the website of Kopiko Student Management System. In the ALB configuration, we also set up the listener and rules. The listener on the port of 80 will receive all incoming traffic, and the forwarding rules direct the traffic to the target Kopiko target group. After configuring the ALB, we copy the DNS name provided by the load balancer and use it to access the Kopiko student management. So now let's move on to the student list page. When we navigate to the student list page, we can see the record in row 1, which is the edited data from phase 2. This provides that our website application is still correctly connected to the same RDS database and that the ALB routing works as expected. That's all for phase 3. Now I will pass to next presenter.
My name is You Zhen, and next let's move on to the phase 4, where we'll focus on scaling and automated monitoring. And in this phase, we transform our architecture from manual management to a fully automated production-ready system. So to achieve our automations, the first thing we needed is a master blueprint. We create a custom AMI named the Kopiko image. And this image is capture the exact state of our functional web server, including the operating system, the LAMP stack environment, and our application code. And the purpose of this AMI is to ensure that every new server launched by this system is identical copy of the original one, and guaranteeing the consistency without manual configuration. And next, we need to tell the AWS how to launch these new servers. So we did this using a launch template. The launch template we name as the Kopiko config, and in this template, we standardize all the necessary deployments. We select the Kopiko image AMI that we just created, and we set the instance type to T3 micro. We also attach the Kopiko web SG security group, which using the group IDs to ensure that the every scale instance adheres to our project security and performance requirements automatically. And now let us look at the brain of this layer, the auto-scaling group. For the auto-scaling group, we name as the Kopiko_AS, and this group manage our flags of servers. If we look at the capacity settings, we can see that the current desired capacity is 2, and our minimum desired capacity is 2, and the maximum is 6. This configuration ensures that we always have at least 2 servers running for high availability, but we can burst up to 6 if needed. And our launch template our launch template is the Kopiko config, and we set the instance type as the T3 micro. For the security group, we connect with the Kopiko Web SG security group. The availability zones is the multi-exec, which we contact the 2 availability zones. So next, to control when to add more servers, we configure a dynamic scaling policy. We use the target tracking policy based on the average CPU utilizations, setting the target value at 60. And essentially, if the CPU load goes above 60%, the system will automatically add the capacity. And now let's look at the result. As you can see, the SG has deployed instances across 2 different availability zones. And we check the target group. These new instances are automatically registered and are showing a healthy status. And this proves our system is now resilient and can self-heal without a human intervention. So next, we're moving on to our communications. We implemented the SNS to keep the administrators informed. So we create a topic called System Alerts, and under the subscriptions, you can see we configure the email protocol to send the alerts directly to the administrator email address. And this ensures the IT teams can immediately notify of any scaling event or the system alerts. And finally, we set up our CloudWatch alarm. We configure an alarm specifically for the HTTP 4xx error codes. And why do we monitor this error is crucial for maintaining user experience and security. A spike in 4xx errors like 404 not found usually indicate the broken links on our website, and it tells us that the users are hitting the dead ends and we need to fix the navigation immediately. Second is the security, which a sudden increase in 4xx error could indicate a security threat, so such as a bot scanning our application for the vulnerabilities or trying to access the unauthorized files. Therefore, these alarms ensure we are notified immediately if users are facing access issues or if there is suspicious scanning activities on our system. And that's all our presentation. Thank you.